Hello, this is Dr. Eddie Morgan at Clovis East High School. Welcome to Homework Help. We're going to be looking in Math 1, Worksheet 2.7b. Remember that each problem in the Homework Help mirrors a problem on your homework. So if you find a problem you're having difficulty with, look at the Homework Help problem with the same number, and you'll probably get the help that you need. So let's get started. The first problem asks us to write a recursive and an explicit formula for the arithmetic sequence. To do this, we need to find two things. We need to find what's the common difference and what's the first term. Okay, so let's look here. Our common difference, notice 12 minus 3 gives us 9, 9 minus 3, 6 minus 3, and 3 minus 0. So our common difference is negative 3. Our first term is simply, what's the first term? 12. Now, given those two pieces of information, we can solve the rest. Our arithmetic formula, our recursive formula, looks like this. It is the nth term, that's not a times n, it's the nth term, equals the term right before it, the previous term. If n is 5, then 5 minus 1 is 4. So it's the previous term plus whatever the common difference is. So notice in our case, the answer is going to be a to the n equals the previous term plus, and in our case, negative 3. All right? So you see where that came from. And I can simplify that and just write my answer as a to the n, the nth power, is the n minus 1 term minus 3. And so that's the recursive. Now for the explicit, it's a little different. It also tells us what the nth term is, but it starts with the first term, and then plus n minus 1 times the common difference. So those are our two things again. So we'll have a divided by n, and then our first term we found up there was 12. So I put in 12 for that, plus n minus 1, and then times the negative 3. Now it's very important at this point that you put the negative 3 in parentheses so that you know you're multiplying it. If you just wrote negative 3 without parentheses, somebody might think you're doing n minus 1 and then subtract 3. So make sure you put those parentheses around there, or it could be wrong. And that is our explicit formula. Problem 2 is an error analysis. It asks us to look at this situation here and see what's the issue. Now, if I look here, I see that the first term is 4, so that's okay, and the difference is 8. Okay, so they've got that right, 4 and 8, that's right. And now my explicit equation is going to be the nth term equals the first term, and the first term is 4, plus n minus 1 times 8. Now at this point you have to remember, if I want to find the 10th term, if I want to find a 10th term, that's going to equal 4 plus, and then I got to put my 10 in here, minus 1 times 8. You notice at this point, if I simplify, I get 4 plus 10 minus 1 is 9 times 8, and there's our problem. If you notice here, they put 10 there instead of n minus 1, which should have been 9. And that's the mistake they made. And so this is going to be 4 plus 72, or the 10th term will be 76. So remember, this other term, you start with the beginning. Your next term is n minus 1. So if it's the 10th term, it'll be 9 times 8. If it's the 11th term, then it would be 10 times 8. Problem 3 says, can you use the explicit formula below, this one here, to find the nth term of an arithmetic sequence with the first term a1 and a common difference d? Well, first thing I notice here is the explicit formula looks like this. an equals a1 plus n minus 1 times d. And if I look at these two, it's obvious I need to get that to look like that. All right? But notice both of these have a d. So you see n times d minus, I could write it 1 times d. So if I think about the reverse of the distributive property, I could take the d out of that and say, okay, this is n minus 1 times d. Notice if you distribute that, you get what you have there. So if I take that and plug it in for there, I'm going to get a to the n equals a to the 1, and then this becomes plus n minus 1 times d, and there is my explicit formula. So yes, I can do it using the distributive property. First of all, to find out whether it's arithmetic, we just need to find out if the sequence, if there's a common difference. So let's look here. From 0 to 0.9, it goes up plus 0.7. From 9 to 1.6, it goes up 0.7 again, and from here it goes up 0.07. So yes, this is arithmetic. Now, to write our formulas, we need to know two things. First, what's the common difference? Well, the common difference is 0.7. And what's the first term? Well, the first term is 0.2. Now, with those 2 points of information, we can now write both of them. So let's first write our recursive. So the recursive, you remember, is a to the n is equal to the nth power, nth term is equal to the previous term, the n minus 1 term, plus d, and knowing where you start. Okay? So to fill in here, I'm going to write my answer is going to be a to the n equals a to the n minus 1 plus my d is 0.7. I also want to state here, you need to say where does it start, and so a1 equals 0.2. And that's our recursive formula. The explicit formula is an equals the first term plus n minus 1 times d. So in this case, we can write it now because we know our d and our first term. So a to the n equals our first term, and our first term is 0.2, plus n minus 1 times our d, which is 0.7. And there is our answer for the explicit term. Number 5 is just like 4. We got to find out first, is it arithmetic? Does it have a common difference? So I go from here, and from -2 to -7 is subtracting -5. From -7 to -12 is also subtracting -5, and likewise here. So yes, this is arithmetic. Now to write the recursive and the explicit, we need to find out what is the common difference and what's the first term. You notice the first term is -2, and we can see that the difference is -5. So let's write our terms. Recursive, this one just says that the nth term equals the previous term, the n minus 1 term, plus the difference, and then state where it began. So we'll write our answer here, a to the n equals a to the n minus 1. Notice nothing changes here. It only changes when we go to add our number here, and we're going to add -5. And then we're also going to state that our a1, our first term, equals -2. So our final answer here, if we want to simplify this a little bit, an equals a to the n minus 1 minus 5, and a to the 1 equals -2. That's our recursive. Now for the explicit, we have a to the n equals the first term plus n minus 1 times d. So we can fill in what we have, a to the n, our first term now is -2, and then plus the n minus 1 times -5. And that is our explicit term. Notice in both of these, all you're replacing is the A1 and the D. Everything else stays the same from your formula. Okay, once again, problem 6. First, is it arithmetic? So let's see what the change is. Notice here, it goes up +6. And then on the next one, it goes up +12. And finally, it goes up what? Looks like 18. So notice, no common difference. It's not the same amount each time. So that implies then that this is not an arithmetic sequence. And since it's not, we're not going to write a recursive or explicit formula for this one. So for number 7, once again, is it arithmetic first? Let's see the common difference, or if there is one. To go from -4 to 4 means we add 8. To go from 4 back to -4 means we subtract 8. And then notice we're adding 8, subtracting 8, adding 8, so there is no common difference. And just like problem 6, that implies not an arithmetic sequence. All right, let's look again, see if it's arithmetic. 47 minus 32, 15. Subtract 15. 32 minus 17, 12 minus 5 is 15. We borrowed 1 here, carry the 1. 15, so we went down 15 again. And then the last one, 17 minus 3, that's 14. So at the end, it went down twice the same, but not the others. So once again, no common difference. It has to be the same on every sequence. So don't just look at 2. If we'd looked at the first 2, we might say, oh, it's a sequence. We got to look at all the terms to see it is. So that implies not an arithmetic sequence. Once again, to find whether it's arithmetic, let's find out what the difference is. To go from -3, from 0.3 to -4 is going to be subtract 0.7. And then from 0.4 to 1.1 is again 0.7. And 1.1 to 1.8 is again to go down 7. So we have a common difference. That common difference, of course, is D equals negative. We're subtracting 0.7. So we can answer yes. This is an arithmetic sequence. Now to write the explicit and recursive, we need to know the common difference, but we also need to know the first term. Well, the first term is 0.3. So now we have the common difference in the first term, so we can write our 2 equations. The recursive first. The recursive says that the first term equals the previous term. If it's n, that means the previous is n minus 1, plus d, and then we state what the first term is. So to write my answer, it's going to be a to the n equals a to the n minus 1. Notice nothing changes there. And now I'm simply going to add my minus 0.7. Okay? And then also then we're going to state that a1, it starts at 0.3. So there's our answer for the recursive. For the explicit term, a to the n equals the first term plus n minus 1 times d. So again, we just need to substitute in d and a1. So a to the n equals the first term. First term is 0.3 plus n minus 1 and then times d, which is minus 0.7. Again, make sure you put the parentheses around the negative 0.7. Otherwise, somebody will think you're just going n minus 1 and then subtracting 0.7. The parentheses is necessary to show that we are multiplying, and that's our answer. This says use the recursive formula that we have right here. Notice nth term equals the previous term plus 2.4, and here is our first term. Find the second, third, and fourth term. Okay, so if a1 is 7.2, then a2 is going to be a1 plus 2.4. So that's going to be, when I plug that in, a1 you see is 7.2. So we're going to get 7.2 plus 2.4. So the second term is going to be 9.6. That's my second term. Now my third term is going to be my second term plus 2.4. Well, my second term was 9.6. So 9.6 plus 2.4. And we end up with an answer. This is 10, carry the 1, 9, 10. This is going to be 12.0. So our third term is 12.0. Okay, and our fourth term is going to be our third term. Remember, n, if that's n, then this is n minus 1. 4 minus 1 is 3. The fourth term is the third term plus 2.4. So my third term was 12. And again, the common difference, 2.4. So our answer is 14.4. And that's our fourth term. Number 11 is an interesting problem. It says, suppose the first Friday of the new year is the fourth day of the year. So Friday would be January 4. Will there be 53 Fridays, whether or not it's a leap year? Okay, first of all, what's the rule that represents it? Well, first of all, the first day is 4. And then the difference is each next Friday you add 7. Okay? So my rule is a to the n is going to equal 4 plus n minus 1 times 7. All right? I'm using the explicit formula right there. So now let's check to see if what it's going to be with 53 and to see whether that works. So let's plug in 53 and see what day that's going to arrive on, how many days that will be. So 4 plus 53 minus 1 times 7. So that's going to be 4 plus 52 times 7. And that's going to be 4 plus, let's see what 52 times 7 is, 14, carry the what? 5 times 7, 35, 364. So that ends up being 368 days. Well, the year only has 365. So as a result of that, we could say there will not be 53 Fridays. Because after full weeks there, you'd end up with 368. There's only 365 days. On the other hand, if we were to check 52, A52, if I just go 52 weeks, as I said, could there be 52 Fridays? Notice here we have 4 plus 52 minus 1 times 7. So we have 4 plus 51 times 7. So we have 4 plus 7, 357. So we end up with 361 days. So as a result of that, you can see that there will be 52 Fridays in the year. All right. Now, whether or not it's a leap year, now a leap year would add a day, but that's still not going to be enough. See, 361, if we added a day, we're still within the range here. And it's not going to hurt it either way. It's not close to 365 anyway. How many full weeks are in a 365-day year? Well, there are 52 Fridays. Since there's less than 365 days, there's going to be 52. There's 52 full weeks in a year. And then an extra day or so. It says, look for a pattern. The first 5 rows of Pascal's triangle, which is here, are shown at the right. Predict the numbers in the 7th row. Well, let's just see what it's looking like here. Our first row has one row. Our second has 2. Our third one has 3. Our fourth row has 4. Our fifth row and our fifth row has 5. So guess what the sixth one's going to be? 6 and 7. So the number of the 7th row will have 7 numbers. Okay. Now a little bit harder, find the sum of the numbers. Well, in the first row there's 1. In the second row, 1 plus 1 is 2. In the third row, 1 plus 2 plus 1 is going to be 4. In the third row, 1 plus 3 plus 3 plus 3, 3 plus 3 is 6, 7, 8. In the third row, in the fifth row, 1 plus 4 plus 6 plus 4 plus 1. So we have 1, 5, 11, 15, 16. So that's our pattern in the second row. And so what do I expect my pattern to be? If I'm looking at a pattern here, obviously if you can see it's going up plus 1, and then plus 3, and then plus 4, and then plus 8. So it's not that. Is it being multiplied? Well, 1 times 2, but then here it's times 2 again, and then it's times 2 again, and then it's times 2. So it's being multiplied by 2. So the pattern is that the number in the row, the sum, is a pattern of 2 to the nth power. When it's 0, 2 to the 0 is 1. When it's 1, it's 2. If I say this is 1, 2, 3, 4, 5. As a result, in the 7th row, the sum of the 7th row is going to be 2 to the 7 power. All right? So that's going to be 2 times 2. You know, if you want to break that up, however you want to do that, that's 2 times 2 times 2 is 8 times 8. That's 2 to the 3rd, 2 to the 3rd. I need one more times 2. So that's going to be 64 times 2, which is going to end up being 128. Transportation problem. It says the buses run every 11 minutes. That's going to be our D plus 11 and starts at 6 o'clock. That's our A1. You get to the bus at 7:16. How long will you have to wait to the bus? Well, this is just as simple instead of figuring out just to do it manually. Okay, if I get at 6 o'clock, the next bus is going to come 11 minutes later at 6:11. And then all I did was add 11. So if we add 11 again, the next bus will come at 6:22. Add 11 again, the next bus will be there at 6:33. Add 11, 6:44. Add 11, and we're going to get to 6:55. Now be careful here. We're going to cross the hour, add 11. So 5 more minutes gets us to 7. That leaves 6. We're going to be at 7:06. Then add 11 again, and we'll be at 7:17. And at this point, notice that we're arriving at 7:16. So if we arrive at 7:16, the next bus will be there in 1 minute. All right, I hope that helped. See you in class again.